Today we start with lab on asynchronous counters. Counters are used to count or perform frequency division in digital systems. Asynchronous, as known as ripple counters, are simple to design because the flip-flop's JK inputs are permanently connected high, which mean we set to 1. This places the flip-flop in the toggle mode of operation, and their output toggle each time the flip-flop clock input receives an active clock transition, as called either as NGT or PGT. Let's start our lab for ripple up counter for mode 8.
For this practical work of asynchronous up counters, we used simulation-trainer-logic.ly. In this simulation, we used 3 JK flip-flop, 3 NOT gate, 1 clock, 3 LED as an output and 4 toggle switch. Bear in mind the clock transition is in GT. To make asynchronous up counters, make sure that the 3JK flip-flop are been set to 1. The first clock connected to first flip-flop as well the clock connected to NOT gate to obtain the NGT pulse. Then for the second and third flip-flop, connect the output the first flip-flop as the clock of the next flip-flop. Make sure before that, to connected the output of the first flip-flop to the NOT gate, then only connected the output of the NOT gate to the clock of the next flip-flop. Record the result obtained in the truth table. As you can see, the LED and counter shown the count up Ripley from 0 until 7. Then, this shown the mod 8 ripple up counter as we discussed earlier.
For asynchronous down counter, as a conclusion, the circuit will count from the MSB to LSB. It means if it is a mode 8, it will count from 7 until 0 and then back to 7 again. The modulus is same as the asynchronous up counter. In this experiment, we use mode 8 which is we use modulus, that equal to 2 power of 3, means that we use 3-bit. But the difference with the asynchronous up and down counter is that the input of the clock of next flip-flop we use the output, Q is the clock of the next flip-flop. But for the asynchronous down counter we use the output of Q bar from the first flip-flop, as the clock for the next flip-flop.